Welcome back, everyone. Next up, we have Ideal Power. It trades on the NASDAQ under the symbol IPWR and is pioneering the development of its broadly patented bidirectional semiconductor power switch, creating highly efficient and eco-friendly energy control solutions for electric vehicle charging, renewable energy, energy storage, UPS data center, solid-state circuit breaker, and other industrial and military applications. The company's focused on its patented bidirectional bipolar junction transistor, B-TRAN semiconductor technology. B-TRAN is a unique double-sided bidirectional AC switch able to deliver substantial performance improvements over today's conventional power semiconductors. Please welcome its President and CEO, Dan Brdar, and Tim Burns, the CFO. Welcome back, gentlemen.
Thank you very much.
So let's get started with the investment highlights. Our B-TRAN technology is a disruptive semiconductor power switch. It has three compelling advantages. It's inherently bidirectional, so it can handle energy flow in either direction. It's much lower loss than conventional technologies such as IGBTs, which results in electricity savings, lower user costs, or if you look at an electric vehicle, improved range. And also, because of those lower losses, there's less heat that needs to be dissipated. So you can actually have smaller, lower-cost OEM product designs incorporating the B-TRAN compared to conventional power semiconductor switches such as IGBTs. B-TRAN's potential is really in some large and growing markets. There's some pretty significant macro trends behind some of those markets with electric vehicles and renewables. Other markets, energy storage, solid-state circuit breakers, and motor drives. We recently, just earlier this year, launched our first commercial product, our Simcool power module, and we expect sales of that product here later in 2023. Our business model is asset light. We do not own a fab, nor do we intend to own a fab. We're really leveraging the existing silicon processing infrastructure that's out there. So we have a core technical team, really looking at advancing the technology, and a small front-end business development team that's engaged with some pretty significant customers for potential adoption of our B-TRAN technology. We do have cash runway potential through at least the end of Q4 2024, so we have a couple of years of cash on the balance sheet and no debt. And the technology is protected by a pretty broad patent estate. We have 72 issued and 24 pending patents. So what is B-TRAN? You can see on the right of the slide here a B-TRAN device. It's about the size of a dime. If you flip that over, it would look the exact same on the other side of the B-TRAN. So what's unique is it's the architecture itself. So just like IGBT is an architecture, MOSFET is an architecture, the B-TRAN is also an architecture. And it's fabricated on both sides of the wafers, unlike conventional technologies. The three compelling advantages I mentioned, the bidirectional switching, that's particularly important in applications involving batteries, where you're charging and discharging a battery. And again, the lower losses, particularly lower conduction losses, but also lower switching losses. And again, the OEM product designs can be smaller and lower cost if they incorporate B-TRAN. So B-TRAN as a bidirectional switch. So if you utilize conventional technologies, you would use 4 conventional devices to make a bidirectional switch. So to handle energy flow in one direction, you'd have an IGBT and a blocking diode. And to handle energy flow in the other direction, you'd have a second IGBT and a second blocking diode. With the B-TRAN, you do all of that in a single device. With conduction losses in bidirectional applications that are better than 4 times better than the IGBT and blocking diode bidirectional circuit. So significant performance improvement over conventional technologies with the reduction in components from 4 to 1. The IGBT market is really the target that we're aimed at with the B-TRAN technology. The 2 largest components of that market are actually already EVs and hybrid EVs and renewable energy. That market overall is roughly a $6 to $7 billion market today. It's forecasted to grow to $11 billion here just in a few years, growing at over 10% per year. Other large segments of that market in UPS systems, uninterruptible power supplies for data centers, and motor drives. So if we look at the segments that we're really targeting here for the B-TRAN technology, the first, electric vehicles and hybrid electric vehicles, it's already a $1.5 billion IGBT market, growing at about 15% per year. You can see here in the image just some of the places where switches are used within an EV. We're really focused on the power applications within the EV, and I'll speak to those here in a moment. So B-TRAN's impact in electric vehicles. You can see here the primary places where you would use a power semiconductor device. So it's the traction inverter, the drivetrain of the vehicle, power DC to DC converter, the onboard charger, places where you need to convert DC to AC, AC to DC, or DC to a different voltage of DC. So again, the traction inverter, the DC-DC converter, the onboard charger, and also circuit protection within the vehicle would be another place where you could utilize the B-TRAN. Interestingly, power semiconductors and semiconductors in general are the second largest cost component of an electric vehicle behind the battery. So they can represent 8 to 10% of the total cost of the EV. We did some work based on some work done earlier by Toyota in improving IGBT efficiency. And using the B-TRAN performance characteristics, we determined that utilizing the B-TRAN in an electric vehicle rather than conventional power switches would improve the range of the vehicle by 7 to 10%. And it would also be much lower cost than silicon carbide MOSFETs that are used by some EV manufacturers today. So it really helps in the two key areas for electric vehicles. One is improving range, and two is reducing costs, which is really necessary to get to mass adoption of EVs. Other key addressable markets, renewable energy, that's also over $1 billion market, growing at over 10% per year. Data centers, about a $500 million market, growing at about 6% per year. We did some work also looking at what the potential impact of B-TRAN would be in a large commercial data center, since all of the electricity that flows into a data center is flowing through those UPS systems. If those UPS systems utilize B-TRANs rather than IGBTs, we estimate there would be over $2 million per year annual electricity savings just because of the efficiency improvement of B-TRAN over IGBT for a large commercial data center. So pretty significant economic impact. A place where B-TRAN is really the enabling technology is solid-state circuit breakers. So the circuit breakers that are used today are electromechanical breakers. They're relatively slow to act. They're prone to things like arcing and wear. But the impediment so far for solid-state circuit breakers, which act an order of magnitude faster than electromechanical breakers, has been there hasn't been an efficient enough semiconductor switch really to enable that potential product and potential replacement for electromechanical breakers. The B-TRAN solves that problem. We have very low conduction losses, which are critical in a circuit breaker application. So we partnered with a company called VTRAN Technology. They're a private company out of the Northeast that has expertise in circuit breaker design. And we had a joint proposal to the Navy for a B-TRAN enabled solid state circuit breaker. They decided to go ahead and fund that program under the Rapid Innovation Fund, which is designed to accelerate the impact of high value technologies. That happened here just a couple years ago. We've been through several runs under that program, wafer runs. We've shipped initial devices to DTI under that program. And we'll be shipping some volume shipments here shortly to DTI as well in advance of a demonstration of a 12 kilovolt solid state circuit breaker at a site selected by the U.S. Navy. The Navy's interest is one of the impediments to date for their ship electrification program is the lack of a highly efficient solid state circuit breaker. So this is something that they're looking at for their fleet. And one of the goals of this program is for DTI to present to the Navy a family of different size solid state circuit breakers from probably 2 kV up to over 20 kV so that the Navy has options to utilize different size breakers in there as part of their ship electrification. So in terms of commercial agreements and collaborations to date, we did enter into our first development agreement for a custom B-TRAN module with a top 10 global automaker late last year. That program, we're actually in phase 1 of that program now, which really revolves around us providing initial devices with our driver to that global automaker for their evaluation of the technology. We're working on trying to secure phase 2 of that program right now. Phase 2 would focus more on the actual development of the custom B-TRAN module. That automaker has selected a innovative packaging company to do the packaging of that module, and we'd be providing devices to that module manufacturer and helping support that work. And then phase 3 ultimately would be the testing of the custom B-TRAN module to the codes and standards required for automotive use. The overall goal of that program is a production-ready custom B-TRAN power module targeted for 2025. We've also announced several collaborations for the testing and evaluation of the B-TRAN technology, including with a different second top 10 global automaker, top 10 global solar provider, a Forbes Global 500 power management market leader, a commercial EV manufacturer, a EV charging company, and a global tier 1 automotive supplier. And that opportunity really came about after we announced the development agreement, where the tier 1 auto supplier actually proactively came to us to evaluate the technology based on just the credibility by association we had from the development agreement with that top 10 global automaker. And then we've completed most of the major milestones under the NAVC program, including our first 2 deliveries, and we expect more deliveries here in the coming months. So our milestones for 2023, to launch our first commercial product, which we completed in January of this year. It's the Simcool power module. It's a multi-die B-TRAN power module, really targeted at that solid-state circuit breaker market. We had a significant inbound interest from large companies in B-TRAN for use in solid-state circuit breaker applications. That really came about as a result of the Navy program that we've been working with for the 12 kilovolt demonstration. We also look to complete phase 1 of that multi-year development program with the top 10 automaker here in the second quarter, complete our first engineering run with a production fab in the second quarter. So to date, we've been utilizing 2 development fabs here in the U.S., but we're looking to qualify 1 or possibly even 2 higher volume production fabs here in 2023. We'll be delivering packaged B-TRANs to diversified technologies under the Navy program here in the first half of 2023. Prior to introducing our second commercial product, which is really taking the Simcool power module and adding a driver to it to make an intelligent power module. The timing for this is the Q3 of this year, and that really targets renewables with energy storage, standalone energy storage, and some industrial markets. So it gives us more shots on goal in terms of the markets we'll look to address here initially in 2023. And then we will be delivering B-TRAN samples for that test and evaluation program to some of those customers that I had mentioned just a moment ago in the second half of this year. Our patent portfolio, 72 issued patents, 31 of those issued outside of the United States, another 24 pending patents. They cover the device architecture, how to control the device, application-specific uses of B-TRAN. And although we have a couple double-sided device manufacturing-related patents, we really treat the process flow on how do you make a double-sided device in a standard silicon fab is a trade secret. So that's something that took us a couple years to develop that process flow. So even if somebody had access to our patents, they still wouldn't know how to make a double-sided device. In terms of recent news, you can see here largely commercialization as we move from development of the technology into true commercialization of the B-TRAN, and now with our Simcool power module. Our shares outstanding, looking at capital structure, just under 6 million. On a fully diluted basis, it's about 7.8 million shares outstanding. Our cash balance as of last reporting at the year end was just over $16 million. For some perspective, we burned through about $6.8 million last year. And again, as I mentioned earlier, no debt on the balance sheet. So with that, be happy to answer any questions you may have.
Great job, gentlemen. Okay, so can you talk a little bit more about the benefit of the company's B-TRAN technology? What exactly makes B-TRAN unique, specifically for the solid-state circuit breaker market?
Okay, yes, for solid-state circuit breaker, the main thing is it's very, very low conduction losses compared to conventional technology. So in the solid-state circuit breaker application, electricity is continuously flowing through the device. So conduction losses, if you have high conduction losses, you're losing a lot of that electricity and generating a lot of heat. So solid-state circuit breakers haven't been able to gain any traction because there just hasn't been an efficient enough power switch. B-TRAN solves that problem. And solid-state circuit breakers are a much better alternative to electromechanical breakers because electromechanical breakers are slow. Solid-state circuit breakers act an order of magnitude faster than electromechanical breakers. And there's also no arcing and no wear that you typically see associated with a mechanical breaker. So It's really the low conduction losses that really enables a solid state circuit breaker to be not only commercially viable, but a better alternative to electromechanical breakers.
And so I'm familiar with your 2023 milestones, but can you elaborate more on your value catalysts and growth strategy?
So for us, it's really the efforts we're taking right now to commercialize the technology. So it's advancing through the development program for the custom B-TRAN module with the top 10 automaker. It is getting devices into both DTI for the demonstration into their hands, but also into the hands of participants in our test and evaluation program, because they're going to have to go through their evaluation of the technology for use in their applications prior to, considering designing the B-TRAN technology into their next set of products. And it's really getting the fab, a second fab that's high volume. That would actually be the third fab. We have 2 development fabs now, so but getting a high volume fab to be able to handle the higher volumes we're expecting now that we've launched our Simcool power module. So it's really a lot of those commercial milestones are going to be really what drives the value of the company. And our strategy is initially it's product sales. So we will be educating these customers about the B-TRAN since it is a unique double-sided technology. But we'll be focused on getting those products in their hands, make sure they understand how to utilize the technology. But longer term, there's a significant opportunity for licensing. So we would be, for instance, for an automotive company who may not want to rely on a small, micro cap public company to supply them with a critical component for their EV platform. We'd be happy to partner with one of the larger semiconductor players that are out there so that they could manufacture the B-TRAN for that automotive company. So I would say right now it's product sales and really to drive growth, but eventually it'll be a mix of both product sales and licensing revenue.
What is the size of the markets you compete in?
So they're very large and growing markets. So electric vehicles, and we would look to displace IGBTs. The IGBT market's already $1.5 billion market, and it's growing rapidly. Renewables, particularly when paired with energy storage, is a great application for us. Renewables is also an over $1 billion market and growing rapidly. I think I had mentioned that the UPS market for data centers, that's already a $500 million market. So with something like solid state circuit breakers, the overall circuit breaker market is about $26 billion, which is really largely electromechanical breakers today. But we're in enabling technology for solid state circuit breakers, and we're looking to displace electromechanical breakers in segments of that market. So there's really some macro trends behind some of our larger markets like EVs and renewables, and almost all of those markets are very large in terms of hundreds of millions, if not $1 billion or more markets. So there's some significant opportunities out there for us.
So when do you expect each of your target markets to generate revenue, and how do you foresee the revenue opportunity and ramp for each of these markets?
For us, initial revenue would be the solid state circuit breaker as we've now launched the Simcool power module. We're looking to actually start selling that product here later this year. So initial revenue would be in that market. That is, I said, we're the enabling technology. So it'll be interesting to see how it works out and how much of that market we can potentially capture. It is obviously a very large market, $26 billion circuit breaker market. Our second product, which is the intelligent power module, which adds a driver really for industrial applications and renewables, those would be our next market. So if you think renewables paired with energy storage, standalone energy storage, EV charging, and motor drives would be potential opportunities for that. Both of those products are looking at markets that typical design cycles can be anywhere from 12 to 18 months to give some perspective on timing. And then the very large opportunity longer term is electric vehicles, is the automotive market. The development program that we're in now, the goal is a production-ready device in 2025. So that's an enormous opportunity, but that's further out than the industrial markets in solid-state circuit breakers and renewables that I'd mentioned.
So Ideal Power announced Simcool this year. So what does a successful launch of Simcool look like for you guys?
So for us, it is really getting initial sales here later in 2023. And ultimately, there's been several large companies that are in that space that have come proactively to us because of the Navy program. it's really getting some design wins with one or more of those companies, because just one of them could drive significant volume for us for that product. So we'll have to deliver those products here later this year, support them through that process, but ultimately it's design wins that will really drive the go-forward revenue.
And share some of your thoughts on Tesla's goal to reduce silicon carbide usage by 75% in its next generation drivetrain.
Yeah, so silicon carbide, there's still some significant challenges, the largest being cost. So silicon carbide can be 10 times as much as a silicon device. So if you want mass adoption or broader adoption of EVs, with semiconductors being the second largest cost component, you really need to address the cost of the power switches. So it's something where they're probably going to use a mix of silicon carbide and silicon devices, but silicon carbide for us is something that we'll potentially look at in the future, because we are an architecture and we could manufacture our power switch in silicon carbide just like we do silicon. But until silicon carbide cost comes down, until silicon carbide wafer quality improves, processing improves, it's not something that we think makes sense for us. But it obviously does make sense for companies that can't sell all their autos for over $100,000 to look at alternatives other than silicon carbide, or just to try to maintain profitability with other costs going up like lithium and the batteries themselves. You need to look for ways to reduce costs. So it's not particularly surprising, I would say, Tesla's announcement. But I think one of the things that is going to drive potential adoption of the B-TRAN technology is the other automakers, the established automakers that are now looking and bringing out EV models are not going to be able to handle the cost of silicon carbide for the general market out there for EVs, for the lower cost market where typically most people buy their cars.
And can you describe the development agreement with the top 10 global automaker in more detail, including the phases of the program?
Sure, and I covered this a little bit in the presentation itself, but we're currently in phase one of the program. We expect to complete that here in the coming months. Phase one is really an evaluation for us of the B-TRAN technology, so the automakers evaluating our power switch, while at the same time they're also evaluating the packaging technology for the packaging company that they selected to be part of the program. As we move into phase two, we'll start collaborating with that packaging company really for the development of the custom B-TRAN module. So instead of just providing devices to the automaker, we'll be providing devices directly to the packaging company that they can start to develop the actual packaging for the custom module. And then in phase three, which is the longest phase of the program, that's really going through all of the testing required for use in automotive applications. It's going through all the testing to make sure it meets the codes and standards, things like shock and vibration for automotive use. And then that will result potentially in, it's targeted for 2025, but production-ready modules for inclusion in their EV platform. So it's a multi-step process. We'll need to perform well in phase one to move on to phase two, but we're pretty confident that we'll be able to secure phase two here in the coming months as well.
And last question from Eric Park. What does it take to get your technology to be the standard? Or is it meant for only a specialty market? If it could be the standard, is it just a matter of education and marketing?
So I think education is a key component of that. For us, it does depend on the application. So there's a variety of different flavors of IGBTs out there today for specific markets. But our technology is applicable to some pretty broad markets that should be growing. So anything involving batteries, where you potentially want bidirectional power switching, where you're charging and discharging a battery, is a natural fit for the technology. Anything that takes advantage of the low conduction losses of the technology, like solid state circuit breakers, would be another place where the technology is a natural fit. I would say that there's some very large markets, renewable energies, particularly if you pair it with storage, which is something that's becoming more and more prevalent, is a natural market as well. So I would say it's some pretty broad applicability. If you look at an EV, though, for instance, it's not going to be the power switch to control the windows or the windshield wipers. It's a power semiconductor device. So it's the higher power applications that really is what IGBTs are designed for. They're high power devices So anywhere where you utilize an IGBT, you can potentially use the B-TRAN power semiconductor switch.
Well, fascinating technology here. We really appreciate you guys coming back with this update. Please come back again. We are excited to see the progress.
Thank you very much.
All right. Thank you, guys. Stay with us, everyone. We'll be right back with our next presenter.